In this video, I'll show you how to solve the ALEKS problem called interpreting a reaction energy diagram. This problem is going to give you an energy diagram, and then it's going to ask you 4 questions about that energy diagram. The first thing we're being asked is to calculate what the heat of the reaction is. This is the same thing as calculating the delta H, or the enthalpy of the reaction, if you are familiar with those terms. And this is given to us by taking the energy of the products and subtracting the energy of the reactants. On the energy diagram, the leftmost plateau is our reactants and the rightmost plateau is the products, because as you probably know, reactions go from reactants to products. So all that we have to do is read the energy associated with our products, which for my graph, that's 250 kilojoules per mole. And then we also just read the energy of the reactants, which is 300 kilojoules per mole. And I get negative 50 as my energy. So that's what I'm going to put down here in this box. Now, if you have an energy diagram that has this sort of a shape to it, where your products are higher in energy than your reactants, you're going to end up getting a positive value for your heat of reaction, because your products will have a larger energy and your reactants will have a smaller energy. So then the next question asks us if the reaction is exothermic or endothermic. My reaction is exothermic, and exothermic reaction is the one that has a negative heat of reaction. If you have a positive heat of reaction, then it is endothermic. And I'm not sure how, what kind of scenario would be appropriate for you to choose neither as your answer. I mean, maybe it's possible if there is one where you got 0 as your heat of reaction, maybe then you'd say neither, I guess. I don't know if that's a thing or not. But if you, most likely you're going to have one of these 2 answers. And if your heat of reaction is negative, that means energy is being released, and that's an exothermic reaction. Then it asks you to calculate the activation energy. The activation energy is the difference between the energy of the reactants and the energy of the transition state. So this high point on your graph right here, this is called the transition state, and the activation energy is just the difference between reactants and transition state. And you want to express this activation energy as an absolute value. So that means no negative number. No matter what, this is going to be a positive number. And we're going to say yes. You got to say yes. You know how to calculate it before ALEKS will let you actually type the number in the box. And for me, my transition state is at 400. I'm just reading it off of the graph right here. And then my reactants are 300. So my activation energy is 100 kilojoules per mole. And again, remember that we're always going to be expressing this as a positive number. And then last but not least, it asks us to determine the activation energy of the reverse reaction. So that would be imagining that this reaction is going in this direction from products to reactants. And in that case, the activation energy is the difference in energy between the products and the transition state. So just this difference right here. My transition state again is at 400 and my products are at 250. So that's a difference of 150. And again, we're always going to express this as a positive value every time. I looked through several different versions of this ALEKS problem and I didn't see anything different than the one that I'm showing you right here. The only variation I saw is whether the reaction is exothermic or whether the reaction is endothermic, but you'll be solving this problem the same way, whether you have an exothermic or endothermic reaction. If you see something weird, just let me know in the comments. Good luck.